I'm dying. AirDrop to my iPad. Okay. Oh, you didn't do a good job. That's okay. So the people are good at. Okay, let's play it. Okay, so that's okay. We'll figure out a way to maneuver. So I want you to pay attention to this marker, right? Can you guys see or no? Oh no, no man. Here. So this is the peak of the thing. So soon as the thing left my hand, so at that moment it has some speed to the object. That's going upwards. Is that okay? So soon as I leave my hand, I have no control over that marker anymore. I don't exert any force the moment the marker left my hand. Is that too hard to understand? Now, what's only force is acting on the marker? Is it gravity, right? So it's gonna have some type of free fall. And that free fall is gonna insert onto the object. And that gravity is gonna pull the marker down while the force still on the way up. So they call it force vector. The force vector is on the way up. But the gravity vector is on the way down. So it's pulling it down. So soon as this marker go into the peak. So let's just say the things left my marker here, the things left my hand, it's gonna have a positive velocity. What happened at the peak? Vertex. But what else means velocity is what? Velocity is what? Zero. Why is zero? You start a millisecond on top. There's no more velocity. So let's just say we describe a velocity going upward is positive. Now gravity is going to pull it down, right? So when I go up to a moment, the gravity is pulling down, but the force is going to redirect because it doesn't have enough energy to climb upwards anymore. It starts going backwards and fall down. Is that okay? Does this make sense? So let's connect to yesterday's lesson. Yesterday's lesson says, well, we talk about, let's see, where are we? Yeah, we taught a lot of stuff yesterday. Oh, there is. Okay. In 1 second, it's falling 16 feet. This is a free fall. Free fall is different. Free fall, just take a ball and drop it. In 1 second, if I measure it, that's going to be dropped 16 feet, 64 feet. And then I'm just going to use different color at the 3rd second. It's going to be this much. So that's just in scale. Each one is 16. And then what else? Next one is going to be 16 times 16. So it's be 16 spaces. I have 9 here. I just need 7 more. And I need a 12 more, I believe. No. 9 more space. So 5. So in terms of scale, that if you take a, I don't know if you guys are good at photographer. I think maybe some of you guys can take a the ball that is very bright and you dropped it and you put in like a different shutter speed. Do you guys know how to do that? Sarah, you know how to do that? Do you think you can take a picture with different shutter speed? Okay, can you teach me how to do that? Okay. Do you have those camera? Okay. Okay, bring him Monday. And then you're gonna teach me how to use that camera because I would like to learn it. So 1 second. Now, if you look at different shutter speed, that you're gonna see that ball have different time. And then 1 second is gonna be dropping this much, 3 seconds drop this much, 4 seconds. It's gonna be increasing distance, right? So that's the thing. That's the idea. That's the free fall idea. So free fall idea is based on this equation. H of t is equal to -16 t squared plus, it's the free fall part. So we're gonna call that this part is the free fall. Are we okay here? But today we don't want a free fall. We want to, let's just say, ask Michael to throw a baseball as hard as I can straight upwards, but on top of a building. On top of a building. It's not on the floor, but it's on top of the building. Emerson, wake up. So on top of the building. Now I'm gonna say, hey, what happened to this ball? When did it reach maximum height? When do they reach the ground? When do they reach everything? So we're gonna do a projectile equation. And projectile equation in math, we are gonna use h of t, which is represents height at any moment. And we're gonna use t, but you can write that as x. It doesn't really matter. But t squared, t is your x variable, which is the independent variable. And the h of t is your dependent variable, which depends on how much time you go through. So this part is gonna be, we know, is a free fall. But the problem is I stand on top of the chair. I throw something up. There's some effect toward the marker. And this effect is going to be V naught T. And you're going to be like, what is V naught? V naught is called initial velocity. It's the time when the ball left your hand. Let's say Michael throw a baseball. How fast you can throw? You ever be a pitcher before?
Nah, I can't really throw right now. I hurt my arm.
But just imagine that you can.
Probably like 80 something.
You can throw 80? Why are you not a pitcher?
Because other pitchers can throw it like a lot harder.
Oh, most of high school pitchers 80, right?
On our team, like people touch 90.
Really?
Yeah.
Well, Robert is already not here. I think
he touched 90.
Okay. No, not this Robert. I'm talking about better Robert. Louis now. Louis the shitty one. I'm just kidding. Robert Herlock. And Derek can throw pretty fast.
Yeah, he can throw hard.
Can you throw 90?
Yeah.
Okay. Oh, I didn't know we have high school that can throw 90. Yeah. Okay, so yeah, I think you guys can throw faster now. So at V0T is gonna be the things that left of your head. Okay, so as Michael knows, if you throw a baseball or rubber, if you the ball that after the ball left your hand, you already have no force acting on it. The initial velocity is gonna be the one that carry over. Is that okay? So Neil says yes. I throw balls too. Please mention about me or McKen. No, right? So both are pitcher. I didn't know that. So I trying to put her on the hot spot. I said which pitchers which one is better? And she's like, I don't want no comment. She feel really stressed out when I ask that question. But I try to start a controversial. Don't worry. So and then also there is an initial position. Depends if I throw a ball on top of building or on top of a 10-foot hill or 20-foot hill, right? So there is a S0. So, so those three things affected. Where's your initial position? So this is the initial position. And this is your initial velocity times time, because also how long that time can travel, right? So it's really three things acted to the the object. So those three things all affected. Now I have all those three things. I say, okay, well, so what happened here, that this is going to become a projectile equation. Now, there was a physics one. Physics one you learn about is negative 4.9 t squared plus v0t plus s0. And that's the difference between physics and math. Robert learned about physics, right? You got to use 4.9t, right? Um, Lena, do you use 4.9 in regular physics? You haven't learned anything yet. Okay, trust me, you're gonna learn more in here than like whole 2 weeks, whole 5 weeks in physics. Okay, so with that being said, is this okay? Charlotte, she's gone. Is my voice that hypnotizing? Yin falling asleep. Charlotte is falling asleep. Today I have to draw like 2 markers. Why not Charlotte? Charlotte's awake. Emerson's not. All right, so are we okay? So now I'm gonna ask you, says, okay, well, I want to draw something up and I want to draw at a certain speed. And I don't know like what's the good number, so I'm gonna go depends on what happened here. Um 80 feet per second. It's pretty doable. Uh what, 96? Uh nope, that's not good. 256. That's not good. Give me a second. Let me get to a number that's. I think this is good. Okay, so I'm gonna say, I'm gonna create a situation. A situation is gonna says, Mr. Ye, Mr. Ye cannot throw as fast as Michael or Robert. I can throw probably 80 feet per second. I have no idea what 80 feet per second is, so let's translate that to math. So let's just say 80 feet per second. How fast do you think 80 feet per second is, Robert? Mile per hour. Probably lower than that. 54. I can definitely do 54, right? Okay. 54 feet. 54 mile per hour. So Mr. Ye is throwing something, like throwing a potato or baseball. So baseball, right? Upwards at 80 feet per second. On top of a building. And you're gonna have to construct this equation of 224 feet height. Okay, I can ask you multiple questions about this. That is dealing with something. So, do you think? What do you think the equation should be? H of t is equal to what? With knowing I throw 80 feet per second, which is roughly 54 mile per hour, and on top of 224 feet. So how would I build that equation? Yes, Bannon.
You just start with the
Good. Plus what? 80 is good. and then plus what? Perfect. And that's it. That was the hardest part. Rest of the part you know. So this function is going to tell you how high is it on any situations. All right, how high is it? And 1 second, I just plug in 1. I'm going to get the height of the ball. Right? So for example, in 1 second, I'm going to get roughly 228 feet high. Because I plug in 1, negative 16 times 1 square is negative 16, plus 80 times 1, so it'll be, and plus 224 is roughly at 228. Is this okay? Now, I'm going to ask following questions. The first question I'm going to ask is find the time when it reached maximum height. And you're going to get exact same question, not different number. Sorry, reach maximum height. B, I'm going to say, hey, can you find the maximum height of the baseball? C, I'm going to say, can you find the time when the baseball reached the ground? Ian? Brendan, you're going to be a bad guy. Just kick him, slap him in the back. Brendan is too nice. Okay, so they got few things that happens. So what are those few things? So I want you guys to suggest me, how do I find all the information? First, how do I find the time when it reached maximum height? Yes, Brendan. On the vertex. Negative b over 2a. Do you guys understand that? Because that is a projectile equation. I could have found negative b over 2a, which is the vertex. How about the second way? I can find both answers at once. Yes. Right, but how do you get to vertex equation? There's two ways to do it. One is using what he said. What is the second way? Yes, Sapa. Completing the square. So we're gonna using negative b over 2a first. Okay. So basically, we're just doing the same problem as what you did yesterday, and we're gonna do it in terms of a word problem or basis problem. So find the time when they reach maximum height is the axis of symmetry because it's a parabola. And we're going to show you that graph of parabola. So t, so for a, t equal to negative b over 2a, which is negative 80 over 2 times negative 16, which is negative 80 over, hold on a second. Let me see. Yeah. So negative 32. So which is that? Can that simplify by 8? So that's going to be negative 10 over negative 4. And that's equal to 2.5. 5 or 2, right? 5 or 2 seconds. We find the time when they reach maximum height. I can throw a 54 mile per hour, roughly 80 feet per second. I throw it upward as much as I can. I toss as hard as I can. Right? And the B, I say find the maximum height of the baseball. Find the maximum height of the baseball. How do I find the maximum height? Yes. Plug in. Good. h of 5/2. Because if I plug in the time to the equation, I wouldn't know the height, right? So it'd be -16 times 5/2 square. You guys are like, oh my god, this is so hard. No, it's not. Plus 80 times 5/2 plus 224, I believe. Just expand it like normally you would do. So 25/4, and you're like, oh my god, this is so hard. It's not. This is going to be 40, so it'll be 200 plus 224. And this can simplify down to 4, so it'll be -100 plus 200 plus 224. And that's equal to 324. It's not hard math, it's just fractions. In calculus next year, you're going to deal with harder things than this. So this is the maximum height. This is the time to reach the thing. Am I going too fast? We did this. Just now it's a more problem. C. How do I find the time when they reach the ground? Hold on, not Brendan. Let's say McKenna. X-intercept. So what means, how do I do it though? But what do you plug in 0 for? Y, which is h of t, right? So it's going to be 0 equal to -16t squared plus what? 80t plus 224. Now for me, I don't like the negative sign on the first term. I also don't like -16 because the factor that require a lot of skills. So I'm going to factor out -16 because I feel like all three number is a factor of 16. So I'm going to factor out -16. I'm going to get t squared. What happens is 80 divided by 16? 5. But that's going to be minus 5t. And then minus what? 14? Are you sure? Okay, good. So now I can divide it by -16 on both sides. So I'm going to get t squared minus 5t minus 14 equal to 0. I'm going to factor this. So t times t. And then what times what equal to 14? 7, 2. Which one need to be negative? 7. Good. So this one is negative. So it'll be t plus 2 and t minus 7 equal to 0. T plus 2 equal to 0. T equal to -2. T minus 7 equal to 0. T equal to 7. T cannot be negative because that's called physical domain. You cannot have a negative time. You can only have positive time. So t equal to 7, 324, maximum height. The time to reach maximum height. So the time reach maximum height this is the maximum height, and this is the time to reach the ground. Does that make sense? So it's not a different question. You just have to convert a word problem to a equation. And then you do an exact same thing as what you did yesterday. It's that you know how to define something. When they reach the ground, that means h of t is equal to 0. When they reach maximum height, that means I'm finding the x value vertex and y value vertex. Okay, so is any way I can knock out a and b and 1, right? So that's is it possible for me to take care of 1 and 2 at the same time? Of course. So h of t equal to -16 t squared plus 80t plus 224. Now I can say parentheses the first two term. I can factor out -16 t squared plus minus 5/2. Just 5. Oh yeah, just 5. 5t. Thank you. plus 224, right? I can take the middle term, divide it by 2, and what? Square. And I'm going to get what? So I'm at plus 25 before. Now, am I really adding 25 before? So check out the net. The net is what? Cancel out. So negative 100. So I have a negative 100 here. What do I need to do in the back? And that's equal to 16 t minus 5 over 2 square plus 324. I got a vertex in one shot using completed square. Because I find the vertex form. Robert is learning more physics in 20 minutes than in whole year in SUG.
Yeah. Would it be like positive, positive?
Or did you show up in SUG though? Did you show up in SUG's class? Oh, you do? Yeah, go ahead.
Would it be positive, positive? Can you answer like X?
Because you factor out, yeah, this one's positive 5 over 2. Okay, yeah, you're right. No, you're right. Thank you. But the answer is still the same in the back. Wait, that doesn't make sense. Why is positive 5 over 2? No, it's negative. It's negative. No, you're wrong. If you factor out negative 16, inside becomes negative. Sorry about it. Michael, you had a question?
No.
You got it?
Yeah, you're right.
Okay. Does everybody understand? If this is a word problem, is that any different than standard form? Absolutely not. It's actually the same. Now you have to transfer that learning into the things. Now, next year in calculus, I'm going to ask one extra thing. I'm going to ask you what happened to velocity hit the ground. Okay, and that's a little bit different. That requires velocity equation, which is taking derivative, which is you can do that. Okay, now what else I can ask you? Now I want to show you certain things. Anything in quadratic and linear table is going to be a slightly different things. We're talking about slightly different things. You know, in linear equation, right? If I just do a comparison, let's just say, who works here? Anybody got a job here? Sam, what do you work? Oh, you work at Publix. How much you get paid? Okay, that's just 12 per hour. So in 1 hour, she got 12. In 2 hours, she got 24. In 3 hours, she got 36. In 4 hours, she got 48. Her job is a linear, right? So let's look at the difference. That's what? 12, right? 12, right? 12. So that's called linear relationship. How do you know something is quadratic relationship? This is very important in physics. Yeah, yes.
The X is the X is the exponent.
No. Bennett?
X the square of the
No, what if I look at the table? Like, just look at the table. How do I know this is a quadratic? 0, negative 16, negative 64, negative 144, negative 256, negative 400. How do I know? Well, yes, but yes. Thank you. Where do you learn that from? Okay, very good. She pointed out something very important. Look at the difference of the difference, because quadratic is square, right? So if it's something to the x, right? 5x or 12x in terms of same salary is 12x. So 12x is x to the first power. So they only look at the first difference. If x to the second power, you look at the second difference. So what I'm going to do, I'm going to look at the second difference here. What is negative 16 minus 0? And what is negative 64 minus 16? Negative what? Negative 48, right? Okay, so negative 48. What's the third difference? Negative 80. Because we use the second number, subtract the first number. The orientation matter. And what happened, this one? Negative 1 what? 112, okay. What's the difference here? 144, okay. So look at a second difference. What is the second difference here? Let's look at here. What is the second difference? So if I look at the table, I can tell this is a quadratic or this is linear by looking at the first difference or the second difference. Very important for AP pre-cal because they have test question like this. You have to understand this is this. You understand so far? So difference of a difference for quadratic. For linear is the first difference. For quadratic is second difference. Okay. Make sure you understand everything on homework. If you don't understand, come after school. The question is going to be almost very similar. If you do your homework, you should do fine on my test. And test is on Tuesday.